Yeah, Rn is 0.53 n square divided by z. Isn't it so simple? Right? This much of Armstrong. Right? Is it true? Rn is equal to, this is equation number 4 on the board, you check it.
Yes, sir.
So remembering like h square, epsilon naught, pi, m, e square, you may forget. But this fellow you can retain in your mind. So Rn is equal to 0.53 into n square by z. You keep in your formula chart, use it, won't lose the marks. Z, the moment they said Z is hydrogen, then you say you can take Z is equal to 1 straight away, right? And if again I remind you, if suppose helium plus, right? So Z will be 2. Lithium plus plus. Lithium is having 3 proton, 3 electron. Now 2 electrons you have removed, right? So it is hydrogen-like element because it is left with the 1 electron. But Z for lithium will be 3 only. So that way the Z is very important. If it is hydrogen, the moment it is written hydrogen, you relax with the just Z is 1. So Rn is 0.53 into n square. So you can put straight away that value. Try it that way. All the question you try it that way. It will be simple for you. Okay. Arusi, have you understood
Yes.
what we discussed? Clear? Yeah. So ZE square by twice. Are you able to see the board on the top? Question number 5. Can you see?
Yes, sir.
Okay. So
Yes, sir.
ZE square by 2H epsilon naught and into 1 by m. Right. Now this for hydrogen Z is 1. So if they are talking about hydrogen, Z is 1. If we are talking about some other, then whatever Z is there, we'll take it. Right. And then they'll be talking, if they are talking, they will talk about the hydrogen-like element that we had seen, like helium ions or maybe lithium ions, correct? And maybe beryllium, later on we can see that maybe. So it is like if some element is having 2 electrons and 1 electron you have removed, then it will be left with 1 electron only. So it is your hydrogen-like element. But originally Z will be the same as 2 only. 2 proton and 2 electrons. Suppose some element we have taken, say for we can take helium, correct? And one of the electron you have removed. So 1 electron in the helium is left out, but Z is not 1. Z will be originally whatever was there in the helium, that is your 2 only. That is, originally it was the Z is number of proton, and that is also equal to number of electrons. 1 electron we have removed, it doesn't mean 1 proton has also been removed. No, that is there. So Z will be for helium, it is 2 only. So helium plus they will be taken. Is 1 electron removed. So that kind of question. Now, why I am discussing this fellow is if I am taking Z is equal to 1, and for the first, you see, for the first n is equal to 1, we got it. V1 is equal to basically E square by twice. You are able to see here, V1 is equal to E square by twice H into epsilon. And that value we got it 2.19 into 10 to power. Yeah, how to say? What is the value? Here it is. Yeah, 2.19 into 10 raised to. Can you see that? Yeah, 10 to power
6.
6, correct. So, that if you remember in the formula chart, because this is your E square divided by 2H into epsilon naught, correct? And that is a common factor here. E square 2H epsilon naught, that is 2.1 into 10 raised to 6. So straight away I can use 2.19 into 10 raised to 6 divided by n. Now for hydrogen we can take n is equal to 1, we'll take that. First orbit, we'll take it like that. Second orbit, we'll take it like